Hi, welcome to How to Shot Web, Better Web Hacking in 2015. My name is Jason Haddix, and I'm the Director of Technical Operations at BugCrowd. I'm a current hacker and bug hunter, and in 2014 I was the all-time leaderboard leader for BugCrowd's platform before I started working for them. My Twitter handle is at jHaddix, and you can contact me on Twitter or through the forums on the BugCrowd forums. So let's go into what this talk is about. It's basically about how to hack stuff better and more practically. And there's a lot of tool presentations in here and time-saving tricks. And basically, I followed a methodology on how to create this presentation and gather all these tips and tricks for you to work from when you're doing bug bounty hunting. So more specifically, what I did is I took my methodology, my bug hunting methodology that I used, and then I went out and I parsed some of the top bug hunters research, web and mobile only for the current iteration. And what this means is I went out and I found blogs that these researchers had started and write-ups that they had contributed to all over the internet on some of their disclosures on their bugs. And I did manual data analysis and basically reverse engineered what I thought their thought processes would be, or techniques or methodologies to find these bugs, as well as where the bugs themselves were presented and things like that. And so I curated it into this presentation and added it to my bug hunting methodology. So what came out of that was a whole bunch of basically discovery techniques, mapping techniques, parameters often attacked, useful fuzz strings and filter bypass or evasion techniques, and a whole bunch of awesome tools to make this work easier and faster.
So the first area we're going to kind of go into is philosophy. So the differences between um, single source testing, which would be like your common AppSec pen test or application security assessment, and crowdsourced testing, there are some differences here. The crowdsourced model introduces um, basically a time aspect that's not hard and fast with the single source testing. So you're racing against time to find any specific bug. You're also racing against other people to find that bug. And the payment is based on impact, not the number of findings. Whereas in a single source test, you're looking for common vulns, not edge case vulns. You're not competing with anybody else on the project. Um, Most of the time, you're incentivized for the count of vulnerabilities that you find doing an AppSec type regular type test, and there's no real way to gauge the success of a regular AppSec test. You may have some good findings, but you really don't know if you got enough eyes on the project. So these are differences between the two types of testing. Each type of testing has its own merits, and I'm not really here to argue, which is better. That's for everybody else to decide. But I did take most of these methods from the crowdsourced model. So if you're just getting into assessment or bug hunting and you haven't seen these two resources before, these are two of the best resources that exist, the Web Application Hacker's Handbook and the OWASP Testing Guide. And basically, this is where you should go to start learning how to hack web applications. These are pretty much the Bibles, I would say, that everybody follows. Any AppSec methodology that you use at maybe a place of work already that you do this type of work for. These are where most of those methodologies start out from. And the OWASP testing guide version 4.0 was just released last year in a release format, and it's really good. And the Web Application Hacker's Handbook second edition came out, I think, a year ago as well. So if you're just getting into this type of work, I suggest you start here, and then you can kind of augment with the kind of stuff we're talking about in this talk and move on from there. So let's talk about discovery of applications. So when you're doing this type of work, you really want to find the road less traveled, right? So we want to find applications or parts of an application that are less tested. The flagship application of a customer is usually heavily tested, right? They've already had a pen test, or they've maybe already had a bug bounty on that specific top level domain. So really what you want to do is you want to find areas where maybe you can score bugs quicker or that have more security vulnerabilities than the flagship site. So let's say acme.com is your flagship site. if the scope allows, and usually will be indicated by star.acme.com, if the scope allows, you want to find all of the subdomains for this top level domain. So there's a couple of good ways to do this, and there's also some other things that go along with this. So you can find subdomains via Google and some other automated tools. We can do this really well with some scripting and some tooling, and I'll show that in the next couple of slides. ReconNG is one I like a lot. You also want to make sure for all of these new subdomains that you find, you do a port scan for them for obscure web servers or services and all these domains. And then you want to go through public data and try to find out if your company has had any acquisitions in the recent history of the company, right? So this one's actually pretty neat, right? So Google has a 6-month rule, I believe, maybe on incorporating sites or companies that it acquires into its bug bounty program. But really, when a company acquires another company, they're really inheriting all of its IT risk and all of its application assessment stuff. And so if the bug bounty scope allows, obviously only testings are in scope, usually acquisitions and sites associated to acquisitions, other brands, are a whole different IT team and probably have a lot of more vulnerabilities than the flagship company application might have had. You also want to try to find functionality changes or redesigns of the site. A lot of times those happen and they introduce new code or new views and things like that, as well as mobile websites because they're basically stood up to handle and render very differently from the standard website. So they often have more cross-site scripting bugs or something like that, CSRF bugs, things like that. And then any new mobile app that comes out for your target could potentially be in scope. So you want to use these methods to try to find new areas to hack on and new applications to look at. And then you'll have a better chance of finding vulnerabilities than you were if you were just to visit the top level domain. So here's kind of the first resource tool that's in the presentation, and this is a quick bash script I wrote around ReconNG. And so what ReconNG is it's basically a framework for doing open source intelligence, but it has a couple modules that are really good to find subdomains. And so this tool basically is a bash script around ReconNG. All you do is you install ReconNG and then you use this bash script and give it a domain, and it'll come out with a whole bunch of subdomains for your site. And the methods it uses to do this are a couple. It uses Google scraping, so it goes out to Google and finds all of the Google results for your top level domain and then parses out all of the subdomains for that site. It does the same thing with Bing and Baidu. It also scrapes Netcraft, which is a common aggregation of server information for any top-level domain. And then it also brute forces based on a common list of subdomains to try to find ones that resolve. So these are like 6 methods or 7 methods here, 6 methods that are common and you usually have to do in other tools or in separately. And so this one will do it all for you. And so there's the GitHub link below. This is kind of what it looks like when you run it. So you do /enum all, the bash script, and then here we've done PayPal, who has a bug bounty. And so after it's done, you can show the results, and you get sort of a listing of all of the subdomains that a company might have. So now these are indicative of whole apps that you can discover, and then you would move on to other parts of the basically discovery process, which you'd port scan each one of these. You would try to find out redesign parts and things like that. So the scraping that tool does for Google basically works like this, right? So when you go to google.com, you can do site.paypal.com, and it'll give you all of the links that Google has for paypal.com. And so then you see that you already know about www.paypal.com, and you already know about www.sandbox.paypal.com. So you use the minus Google search operator there to remove those from the results. And basically you do this many, many times iteratively out of the results. So every time you find a new subdomain, you add it to your list that you've identified it, and then you minus it out using the minus search operator. And you keep on doing this until you've exhausted all of the subdomains that Google has. And so here you can see, what that comes up to. So I no longer see those two that I minused out, but I see new ones come up to the top of the list, and this is what that script automatically does for you. So it gives you a ton of new apps to look at while you're doing your assessment. To kind of garner lists of mergers and acquisitions, Wikipedia is actually a really good place for this on the bigger bug bounties, so like Facebook and Google. People keep this information up to date for stock reasons, but it's just as useful for bug bounty hunting. You can see that they've acquired certain groups, so you can make sure to check their scope on their scoping page to see if these groups are included or might be included in the bug bounty, and if they are, or they're not explicitly excluded, you can start to look at these properties as well. There are also some people who keep up some lists of previous bugs for the bigger bug bounties. So like the Facebook bug bounty. This is a link to, I don't know why he does it on the Facebook page, but he keeps all this information on the Facebook page. He basically goes out and collects links for bugs that have been found in different types of bounties already. So here you can see a whole list of XSS flaws and logic flaws and race conditions. And you might be asking, why is this important if these have already been found? Well, a lot of times you'll find the same bugs in other parts of the application, and so you want to regression test all of these types of bugs across other applications, maybe where they forgot to implement a protection in one part of the app where maybe they fix the flagship app like we were talking about earlier. It also just gives you kind of a good feel for where the app has been vulnerable before, and tips and tricks, and paths to follow down, and what kind of bugs you can look for in that type of application. Obviously, there's some privacy and spam in the bottom right-hand corner here. Those are types of bugs that are usually pretty specific to Facebook, right? I mean, not a lot of other applications are social networks, so you don't get certain classes of bugs where you're leaking privacy information, or you're allowed to spam other people, or anything that has to do with friending. So it just kind of opens your minds to the possibility of certain types of bugs in an application. So the next part is port scanning, and so like port scanning isn't just for network penetration testing. You can find all kinds of great stuff on the internet using port scanning, but specifically for bug bounty hunting, once you pull down all those subdomains, you want to do a port scan. And so what you'll start to find doing port scans is you'll start to find separate web apps, extraneous services. Facebook had this bug in specific that was highlighted on the right hand side, where it had a Jenkins script console with no authorization on it, and all this user had to do was port scan, find it, connect to it, and basically own the server. So IIS.net, Microsoft's marketing page for IIS, had RDP open and vulnerable to a common vulnerability there, and so that wouldn't have ever been found without port scanning. So it's quick port scanning syntax with Nmap is just do a syn scan of all ports without any ping, and then use the script, the Nmap script, to pull out the HTTP titles. And so that's a quick syntax you can use. I know everybody has their own kind of like Nmap syntax they like to use when they do port scanning, so you can use your own, but that's the one I usually just run very quickly when I start to see new applications and I want to port scan them. So then you have to go into mapping, and so we'll talk a little bit about mapping here. So some mapping tips that you can do is basically you can start to Google your application and basically pull out types of parameters it's gonna give you back. But that's a kind of a time consuming effort. I mean, you'll see common parameters and stuff in URLs, but yeah, that's you'll get most of that when you spider the sites themselves. But there have been instances where I've been able to use Google Docs to pull out certain types of vulnerabilities. So you can query Google for site.acme.com and then search for redirect equals, which would be like a parameter that would be indicative of a redirect, and you can still get hits and interesting parameters from Google. So you can do that. The next kind of part of this is finding unlinked resources, so things that haven't been spidered or that maybe aren't supposed to be on the website. And so this is usually directory brute forcing. So you have acme.com, and you keep on requesting after acme.com a whole bunch of things that you're looking for. So like control panels, like /admin, or configuration files, or like git setup files, or things like that. And so in the normal workflow here in directory brute forcing, you would use something like Dirbuster or Potador is another one that a lot of people use, tools to brute force web URLs or web URIs. And the lists that are included in most directory brute forcing tools they're okay, and I still use them a lot, but I find a lot better results with these three resources. So those lists are built in a way that they went out and spidered the internet and found the most common paths after your top level domain, so after acme.com, and then they included them in this list so that you could do directory brute forcing and find these things. And so that's really great, but we're really trying to look for things that don't want to be found. So the raft list is the first thing on this list down here in the bullets. And basically what the raft list did is they went out and found, or they spidered for all of the internet's robots.txt files, which are, if you've ever managed a website before, you know that robots.txt is actually a listing of places that the website does not want you to spider, and so the things they do not want you to see. So they made a brute forcing list out of that information, and it's tremendously valuable. I can't tell you how many times I've gotten some type of hit from the raft list. And so the raft lists are included the directory brute forcing list inside of the seclist project, which I help run. There's also a couple other projects that are worth mentioning here. So SVN Digger is a project that went out and spidered all of SVN. And so if you can identify that it is an open source project and they use SVN, you can basically pull down all of their pathing and do a directory brute force with that pathing from the SVN Digger project. And the same goes for Git Digger, except for with Git projects. So some great resources there for directory brute forcing and finding unlinked content. So platform identification. So really what you want to start doing after you find some unlinked resources and you want to get a better feel for the application and identify its tech stack is I use a couple of simple Chrome plugins. So Wappalizer and Built With just sit in the upper right hand corner of Chrome as an extension. You just click the button and they will tell you the full tech stack, and they do this by looking at the headers. They do this by fingerprinting the comments on the page. They do this by looking at the response size and type and any links, offsite links that they're connecting to, and they'll give you a visualization of the full tech stack that site is using, and that gives you a really good feel for what you're supposed to be doing next. Or what kind of vulnerabilities you might be looking for based on that tech stack. Retire.js is really cool. There's a command line version or a BERT plugin, and basically you can run it on an application and it'll tell you if it has any outdated server-side JavaScript libraries, so like Node or stuff like that, and it'll actually give you vulnerabilities associated with outdated version. So it's a really cool one right now to use. And then you want to take this information that you get with Wappalizer and Built With and Retire.js and check for CVEs based on those outdated versions that you might pull back. And those are really easy wins when you're doing some web testing. And then if you find, in this type of testing, or in this type of identification and mapping, if you find that you're up against a CMS like WordPress or Joomla or Drupal, there's two basically industry standard tools right now which work to scan those content management systems and find vulnerabilities for you. And so that's WP Scan for WordPress and CMS Map for everything else, for Drupal, Joomla, and everything like that. And so they will actually go and they have large databases of the plugins that these CMSs might use. And so they will profile your target for all the plugins and then tell you which ones they found and if they are old versions, and if so, what vulnerabilities might be associated to an old version of the plugin. And if you've ever done any of this type of work before, you'll know that most of the vulnerabilities actually don't lie in the core of the CMS, they lie in the plugins. And so here on the right, you can see just a screenshot I grabbed of WP Scan somewhere, and there is a theme associated to this WordPress install, and it has a file upload vulnerability, and so it gives you really pointed information as to the reference of how to reproduce a vulnerability and all the plugins. No plugins found on this one, but also themes, and it'll also enumerate all users for the application should you want to do some username brute force, stuff like that. So this is just a reminder of kind of the directory brute forcing workflow. So a lot of people do directory brute forcing, and they will do it off of the top level domain, so acme.com, and they will brute force. And so an example would be they request acme.com and they get a 200 response, and then they request acme.com/backlog and they'll get a 404, so they know that's not there. And then they'll go through and request acme.com/control panel and they'll get a 401. And then they'll move on and keep on going down the list. And since they got a 401 not authorized, they'll stop there because they didn't get any content back. It was not basically, they didn't get anything they can use. But a lot of people don't brute force past the first 401 that maybe they found, or any arbitrary status code that's not a 404 or something like that. So you really have to brute force past that as well. I found many of vulnerabilities based on misconfigured access control of a website. So if you brute force past that control panel, you might find a directory or basically a page that has no access control on it, and you would miss that otherwise. So I see a lot of junior pen testers missing this type of stuff. So I would check this out. The next thing you want to do, or at least that you can do, is do some mapping and vuln discovery using open source intelligence. And so there's a number of sites, basically 6 examples here, where these communities are already out there testing for cross-site scripting on all kinds of major sites. So xss.com, Reddit/XSS, PunkSpider, XSS.cx, and XSS Exposed. These are all places where people who are really good at XSS will post their basically conquests saying that they XSS eBay or PayPal or something like that, right? And they don't necessarily always submit these to the bug bounty program. Sometimes it's more for just pride. So you could actually get some quick wins by visiting these sites and checking to see if your target has any results on there. But a lot of times they might be already taken, and that's totally fine. You still use these. You can still use these though to basically figure out how they were vulnerable at one point in time and see the attack string that the attacker might have used, and then do some kind of filter evasion or something with the same attack type, and maybe you can pop the same type of XSS as a bypass and submit that to a bounty. So really they help you get a feel for the flaws that they've had in the past and guide you to further injections and stuff like that. So these are really worth doing. And you can also search on Twitter. A lot of people talk about their stuff on Twitter, so you just search a large Twitter feed for something.x, some customer, and then XSS in the same word, or CSRF, or any type of vuln category as well. So use OSINT to kind of get a feel for where things have been vulnerable, and attacks that might be going on that you can leverage and help you map and find vulns. So this is a new project. I didn't do this project myself. Actually, when I presented at DEF CON, I brought up my intern to present this part because he did this. But basically, it's a project called Maps that he started. And what it does is it basically brings in all of the bounty programs that exist out in the public space, 250 plus bounty programs. And it starts doing some general crawling and brute forcing on them, and also collects all the metadata associated to that bounty. So any links to the targets, rewards that they offer, and what their payment method is, what is the scope of the bounty, and then you can forward all of that data into another tool that we're going to go over called Intrigue that my boss Jonathan Cran actually wrote, which is super cool. So the Maps project is really cool. You can start to basically mass scan for all of this information for any given bounty out there. This is kind of a little snippet of the JSON data that it can provide. So you have a program name, which is Yahoo. You have a reward type, a reward low, a reward high, what the scope is for sites, maybe mobile apps that are associated to the site, DNS information, and you can just pull out more and more information. So you're already prepared to do this bounty type work right away when using the Maps project. So Maps will also do some crawling and basically using Ruby and JSON and grep, and you can take the output files from the Maps project when you feed it something, and then just use grep to pull out parameters out of the output. So here you can see we grepped redirect, and we found a whole bunch of links that obviously not we didn't include the target here, but you can see that there's a redirect path and then a redirect URL, and so you'd want to fuzz these things for redirects or remote file includes or local file includes or something like that. Everything after the redirect you would want to test there. So you can start to pull out large-scale sites and parameters and stuff out of projects like this. So the other tool, Intrigue, is an OSINT framework that Jay Cran has been working on. Jonathan Cran, one of my boss here at BugCrowd, and it is super sweet. So it's an OSINT framework. It's pretty simple to integrate, but it has all of these modules that you can use, like DNS subdomain brute forcing, a web spider, Nmap scan. You can see on the right-hand side just the plethora of type of data that it can pull out, and it's all set up via web APIs and everything like that. So you can go to GitHub and play with Intrigue. It's called Intrigue.io. This is an example of kind of a module. You're looking for DNS records here, and then you can see that it's sent this module to a worker and has started the task at the bottom. There's just some command line output. And here is some output. So you can see a task ran. The task was DNS sub brute forcing, and it ran on Intrigue in this case. So here you can see some output. So it found api.intrigue.io, blog.intrigue.io, calendar.intrigue.io, et cetera, et cetera, et cetera. And so you get this HTML output as well as text data and command line output for these modules. And so the cool thing about Intrigue is really it's not just DNS sub brute forcing, but it has a whole bunch of modules. It's all scriptable. If you've ever used tools like Maltego and Foca and any of these other OSINT type tools, you know that they all have their shortcomings and they've never really been brought together, and you have to kind of use them piecemeal. So Intrigue actually brings everything back together and also has this wicked API that you can script against and just do whatever modules you want and kick them off all at the same time. You can input ranges in to pull this information back instead of just giving it one site or something like that. So Intrigue is really sweet. I suggest that everybody check it out. So the next area is authorization in session. So authorization and session bugs, there's a lot of small bugs associated to these sections of an application or these types of vulnerabilities. And that's cool. They get found really quick, and sometimes they're actually even set to out of scope. Companies may not want to know about these types of vulnerabilities. The fact that you can iteratively find what a valid username is by using the login page or the password reset page. They don't care about no account lockout or a weak password policy or password not required for account updates. So you can see these vulnerabilities in the application, and they might be out of scope. It's still not a reason not to mark them as useful. So a lot of times when you're doing this type of testing, you'll have issues where you need to chain vulnerabilities together, and just from recent memory, I can bring up one that uses this type of a couple of these on this list. So recently there was a site that allowed a password reset, and the way they did their password reset was instead of sending you a link to visit their site like most other sites will do, they'll send you an email and you click on that link and then you go to the site and reset your password. Instead of doing that, this company just reset your password. And so they had a really weak password policy, so they were setting it to 4 digits, 4-digit number. And then they had no rate limiting on their login page, so there was no account lockout when you tried to use a password over and over and over on someone's account. So combine those two small issues that normally would have been out of scope in some bounties actually made it so that you could do a full account takeover, right? Because I would put in, jason@site.com for the password reset. It would send me a password reset, and then as long as the user didn't change their password in that time, you could brute force that 4-digit character, which only took I think something like 15 minutes or something like that to get all four digits brute force completely. And and you could take over anyone's account. So these type of vulnerabilities, even if they're out of scope, if you find them, keep them like written in notes. I usually keep Evernote open when I'm doing this type of testing and just keep them as notes so that later on when you're doing like a cross-site scripting or you're doing something else, some other type of attack, you might be able to leverage these to do more critical attacks and prove your threat scenario a little bit better. So session's kind of the same deal. Failure to invalidate cookies, no new cookies on login, logout, or timeout, never-ending cookie link, multiple sessions allowed, easily reversible cookies. These things are sometimes out of scope as well, but just keep them in your notes because they might come in useful later. If they are, if they aren't, you can actually just submit them as vulnerabilities. I mean, these are all pretty basic session things that shouldn't happen unless you have like a very good use case to have them happen. So the corrupt or the basically the big part of this presentation is actually fuzzing for vulnerabilities and some tactical ways to do this fuzzing. I don't know who came up with the term tactical fuzzing. It was a couple years ago that I heard it, but I really like it because it gives me some more information around fuzzing that I didn't usually have. And so I brought back some tips and tricks from the research that I garnered. So the core idea of cross-site scripting, which is the first one we're going to look at, is does the page functionality display something to the users? And for time-sensitive testing, I kind of use an 80-20 rule here, and many testers really do too. So one of the weapons in this kind of arsenal is using polyglot payloads. And so polyglot payloads are basically payloads, fuzzing payloads, web payloads that will execute in multiple different contexts. And you've probably used these already, used at least one of these in your testing already. So the first one is this one. And so this is a multi-context filter bypass based polyglot payload. And this is the one that's in the RSnake XSS cheat sheet, or actually used to be, now it's the OWASP cross-site scripting testing cheat sheet, I believe. But here you can see that we're trying to evade filters by using string from character code. We're using, we're trying to execute in multiple contexts and things like that. So this is the one that a lot of people have used. And cross-site scripted testing isn't super hard anyway. You could just put in your meta characters and see what they come back and code it as. But to do a blanket injection that will render in different contexts is actually super useful for time-saving purposes. So here's the next one. This one is done by Sharjah Ved, who did a whole bunch of XSS research. He actually has his PhD in cross-site scripting, filtering, as well as attacks. He used this string specifically to XSS, I think, something like, I'm just ballparking here, but probably like 80% of the Alexa top 1000 or something like that. Maybe that's the high estimate. It was a lot. And his presentation on everything is linked in that link in the bottom right-hand corner. But this is a multi-context filter-based polyglot payload, filter bypass-based polyglot payload. And so here you can see that he's ending a whole bunch of tags. He's trying an input that's an image. You can see that he's including an email domain to pass email filters. He's doing all kinds of stuff here to try to evade certain filters in one string and execute cross-site scripting. And so this is a good one to try immediately. And what you're doing with these polyglots is you're basically going to your site, and if you're on this kind of timetable because you're doing a bug bounty, you're finding the sensitive areas of the site, which are the registration area, the login, the search bar, the comment field. So these are all the types of place where you're going to want to plug in these polyglots really quickly just to see if you can get a hit. This is another one. This is a multi-context polyglot payload by Matthias Carlson. And he's done a whole presentation on web-based polyglot payloads, and that's associated to the link under his name here. But this one will alert in several different contexts using ticks and forward slashes. Some other XSS observations when I parsed all the research of the bug bounty hunters and actually my own findings. There's a lot of interesting input vectors associated with cross-site scripting that a lot of people will miss. So anytime you have a site that has a customizable theme or a profile and lets you input your own CSS, most likely it's going to be vulnerable to cross-site scripting using that editable theme or profile function. And any names of events or meetings or anything that you schedule is usually vulnerable to, or can be vulnerable to, cross-site scripting, to stored cross-site scripting. Adding URI-based strings will sometimes execute based on whatever the page is rendering. This is one that happens actually a lot. So if you have a site that's importing Facebook data or integrating with Facebook, obviously Facebook protects itself from most cross-site scripting attacks, but when you can set your Facebook or your test Facebook account to a script tag or a cross-site scripting attack, and then a site that you're working on who is importing that information might not escape those characters, the characters that are usually causing the cross-site scripting, and so you can import data from Facebook and actually execute cross-site scripting based on the integration. And so that's a really good one. JSON post values. So anytime you see a web service that's not filtering output, make sure to check it's returning its correct content type. Otherwise, you can execute cross-site scripting there. File upload names. So when you're uploading a file, changing just the name of the file to a cross-site scripting attack, because eventually that file might get rendered, the name might get rendered somewhere, and you'll hit on that. Uploaded files is a really big one. So actually uploading a file that contains code that'll let you execute cross-site scripting. The most common ones being a Swift file or an HTML file. This happens all the time right now, so that's a good place to look. And we'll go into file upload vulnerabilities in a little while. Custom error pages, so people reflecting output on error pages, adding fake parameters to the URL, and either error pages or 404s returning with your attack in them, and then login and forgot password forms. These are all more places where you can look for cross-site scripting that seem to go either underchecked or unchecked from a normal methodology. So one of the things that I saw a lot of as well was Swift parameter XSS. So anytime that you find a target of yours has uploaded a Swift file to do playing media or anything like that, they all have what's called flash variables associated to them, or basically parameters that you can add to the end of the Swift file to do certain things. And these things are always, I don't think I've ever come across one that hasn't had a cross-site scripting or remote file include vulnerability in them. So there's a lot of media players that have these common parameters like onload or loud domain or movie player, XML path or event handler, all these type of things. There's actually a whole OS page on testing for Swift parameter XSS. And then there's some common injection strings, although with these it tends to be that you need to manually figure out how to execute them. But there are some tools that help us here to do this. So Cure53 has a project called Flashbang, and what this project will do is it will take a Swift file, so all you have to do is download it from your target site, and then you basically use this code to parse or to disassemble and parse the Swift file. And what Flashbang does is it's probably the best tool right now to basically give you all of the parameters that might lead to remote file includes, and it will give you this in a concise list after it has decompiled the code. So a lot of the tools in this space are old and haven't really been updated for decompiling Swift files, and they don't give you pointed information as to what the parameter structure is. And so this tool will actually give you, it'll give you the flash file followed by the parameters that you want to test, and it'll give you values as to whether it needs to be an int or a string or something in that parameter value. And so it just makes it really easy to find cross-site scripting or remote file include vulnerabilities in those Swift files when you saw them on your target. So highly recommend that tool. So SQL injection is another area that's a big time vulnerability that you want to be checking out. The core idea behind SQL injection is, does the page look like it might need to call on stored data? And so you can start eyeballing that when you get to a target site. But for the polyglot idea that we were talking about earlier, where you have one string that might execute in different contexts, there does exist a SQL injection polyglot that Matthias Carlson talked about in his presentation. And so this is one of them. You can see here we're using asterisks and forward slashes and ticks to basically break up this one string. But this string works in a single quote context injection, double quote context injection and works straight into the query as well context. And so you can get a little bit more information about how this works and how that breaking with the asterisks and the ticks and the forward slashes actually will make a SQL parser render one of these correctly, and the other two just get discarded in Matthias's presentation. But it's kind of a cool idea to be able to use one string, and obviously you want to increase the sleep value here to check for what would be blind SQL injection, but you want to check out his presentation on exactly how that works. So there's also a large database of fuzzing lists that I use in this type of testing. So the seclist project, it's Daniel Miessler /seclist, and I run this with Daniel. We basically curate a large number of fuzzing lists that you can use to do either certain types of attacks or attack certain types of DBMSs. And so this is actually a fork of the fuzz database, and we've included a whole bunch of extra stuff in our project. But here you can see we have generic blind injection lists on the right. We have MS-SQL specific, MS-SQL enumeration, just general SQL meta characters, login bypass strings from MySQL, and this is only a short listing of what's prepared in the fuzzing directory of the seclist project. So usually when I'm doing SQL injection and I've managed to just kind of get a feel for what I think the database is, I'll start going through these fuzz strings and looking at and loading them into burp, and you can just load them into burp using intruder and start attacking parameters that you think might be vulnerable to SQL injection. So just some SQL injection observations is blind is predominant, error-based is really unlikely nowadays to find error-based injection. It doesn't happen a lot. There is some tooling around SQL injection, but really SQL map is still the go-to tool. I haven't found a bug hunter who, after identifying SQL injection through one of those fuzz strings and gets a good feeling for that it's actually there, hasn't used SQL map to exploit it, just because blind SQL injection is such a pain to actually exploit and pull stuff out of. So some tips with SQL map when you're using this to do your testing: you can actually take a whole burp log file from burp when you set up logging and run SQL map across all the parameters using the -L switch using SQL map, and that takes forever and might not be your bag, but it's definitely useful in some situations. You can also use tamper scripts in SQL map. So tamper scripts are basically sets of encoding rules that SQL map will apply to any of its fuzz strings to try to evade blacklists or filters. And so there are DBMS specific tamper script rule sets that you can find, and so there's actually a forum post on the bug crowd forums that I did, which has, like, if you're up against MS-SQL and you're hitting some kind of blacklist, use this syntax for SQL map. And so those are really useful when you're going through, and I might actually add those to this presentation at some point. And then another SQL map tip is just is if you want to instrument SQL map quickly, there's a burp plugin called SQLi Pi, and basically it allows you to right-click on any request in burp and send it to the SQL map API and start SQL map really quickly on one request. And so having used like repeater and some of these strings, and maybe you've seen some iffy behavior from the application, being able to quickly send it to SQL map without using the syntax every time is actually saves you a little bit of time. And so then there's just a lot of just some other common parameters or input injection points where you can see SQL injection in the right-hand table. So any ID parameter, currency values, item number values, any type of sort parameter, JSON and XML values, those are things that get missed by a lot of scanners nowadays, so just make sure you're fuzzing those for injection as well. Cookie values, headers, and REST-based URLs that have values in them. So these are some common places where injections were found. Obviously, these are parsed from the research I did on common bug hunters vulnerabilities, so they came up multiple times in that research. Here's an example of that tool SQL map, SQLiPy, which basically I have a request on the left, and I just right-clicked it and do an SQLiPy scan, and it'll send it to Burp's scanner or to the API, and then when it finds something, it will put it back in the results queue for the scanner. It actually doesn't look like this anymore because Burp has changed their window where the results of a scan have actually moved to the target window, but you get the general idea. Um, Additionally, when you're doing SQL injecting, you might need some more information around certain types of techniques or attacks to do certain things like privilege escalation or how to pull out certain system information. And so these are a collection of cheat sheets that I use all the time for this, broken down by DBMS types. So you have MySQL, MS SQL, Oracle, Postgres, and then on the bottom a collection of others, which is like Ingress, DB2, Informix, SQLite, and Active Record. And so these are all basically cheat sheets for those DBMS types and attacks that you can do with them. There are some older resources on here, like Pentest Monkey's cheat sheets are kind of old, but they're still the best. These are really I've curated them down to this list, and this is probably what you should be using when you're doing SQL injection. And like I said, I keep an Evernote open with all of these resources when I'm testing, so that I have these as soon as I might have identified some type of injection. So, and these are all hyperlinked in here, so you can take them back and look at them as well. So file uploads and file includes. So for a local file inclusion vulnerability, which is basically you've managed to, the server interacts with the file system in some way, and you can tell it to interact with its own file system and pull out a file or display the contents of a file that it may not have wanted to do. So the core idea here is, does it or can it interact with the server file system? And so here there's a tool to automate this called Liffey that just came out. I've used it a couple times. It's pretty cool. You can also use the seclist LFI list here to do custom fuzzing in Burp. And so you can see that that the contents of that file has a whole bunch of filter bypasses, as well as just general trickery as to execute out or to read out local files, as well as files that are commonly available, like Etsy password or Etsy shadow, things like that. Some common parameters or injection points for this type of work that basically existed across the research was file, location, locale, path, display, load, read, and retrieve. These were the most common for LFIs. For file uploads, this is a really hard thing to do right. So a file upload function needs a lot of protection to be adequately secure. So some of the most common attacks that we saw with uploading files are uploading an unexpected file format to achieve code execution, and this was kind of mentioned earlier on, but there's some extra tricks in this area. So things like uploading a SWIFT or an HTML or a PHP or PHP3, these are the normal types of things you do when you're doing web testing, is you try to upload a web shell, right, doing this. And hopefully the server takes your upload, and then you can visit the page where that shell landed, and you can execute code. This still happens, but it's less likely nowadays because extensions like PHP or PHP3 or any executable code that goes up, like ASP, something like that, is actually filtered out. So you're most likely going to hit better with Swift and HTML and things like that. But you can also execute attacks like XSS via images and file types as well. You can also attack the parsers for these image uploaders and things like that. So some examples of these are like the parser that handles images on a certain web framework or website. The parser was taking the image and allocating space based on its header data. And so you can upload a really small file that was within the bounds of what the filter was looking for, but then in the actual metadata of the file, the actual binary data, you could say that the file was super, super large, and so it would get past the filter, and the web server would allocate all of this large space, and you could basically DOS the site with this small image because it was trying to allocate so much space for this image when it was actually just a small image. You can also do things like storing XSS payloads via the metadata or the file header of an image, and if at any point the site takes that information to do something else, it'll execute cross-site scripting. And then you can do some really interesting things like upload malware on servers via what's called file polyglots. And so we talked earlier about web-based polyglots, which are web attacks that can execute in different contexts. Well, these are files that can execute in different contexts, and we'll talk about that in a couple seconds. So for file upload attacks, for techniques, really there's a presentation by Suresh Dalili, and he goes over all of the common types of trickery to get file uploads to work. And I think this has actually been mostly parsed into the OWASP file upload testing page, but I'm not sure everything has, but it includes content type spoofing, extension trickery, and everything like that. So I would highly recommend parsing all of the tips and tricks from this presentation, because every one of them is super valuable. Although it was made in 2012, it's still very relevant to today. And so I would use this in the OWASP page for that, to get like the general feel for file upload attacks. Like I said, there's some ways to use file polyglots and store malware on servers. Now, the threat scenario here is really interesting because what happens is you can see on the right-hand side there's all this text, right? But basically, these are files that Dan Crawley and Angel Bertini have created that will execute in multiple different contexts. So it could be a PDF or a zip or a flash file or an ISO. It's all one file, and they can execute as any one of those things because of the way they've crafted this kind of sandwich of code. So like if you're Flash, you're looking for like the Flash header, and you just ignore everything up until a certain point until you find the Flash header, and then you execute it as a Flash file. Same thing with ISO or PDF or whatever, right? So if you can make an executable that's also a PDF, I don't know if that's one of these on here, and the executable is a malware installer, but you're uploading it as a PDF to a server, you're technically storing malware on somebody's site, and you could use like Google or somebody as like a malware clearinghouse. Now, whether this is considered a vulnerability or that the client can actually protect against and eligible for a bounty is really up to them. But I think it's an interesting thing to think about as we go forward in web testing in general, is just how a lot of these files can be construed as multiple different things. And the protection here actually has to be very robust, because you have to start looking at the header and parsing the binary itself when people upload stuff. And that takes a lot of resources, as well as a really good parser that probably doesn't exist at this moment. So just some interesting research, and they have a whole presentation about it that is linked in here. So I've never been paid for this vulnerability, but people have patched it before, and I just think it's kind of a cool thing. So the next one is remote file includes, so including executable code from a PHP, or sorry, not a PHP, but a parameter path. So there are just some general redirection, and remote file includes parameters that you can check for: destination, continue, redirect, URL, URI, window, and next. And at some point, I think that someone at the DEF CON talk said they were going to take this this presentation and all of the tables of the common params and actually just do a burp extension and alert anytime it saw one of these parameters, so that you could kind of follow that path down to see if it was vulnerable, or you just got a prioritized list of things to look at. So I think that'll be pretty cool. I just eyeball it when I'm inside of burp, but that would probably be more efficient. So when you're doing redirections or using remote file includes, a lot of times your path and your forward slashes and backslashes are sometimes encoded or just filtered or something like that, so you can't do the exact attack. There's some multiple blacklist bypass lists on the left here, so you can different ways to escape and try to encode dots or slashes or things like that. And so those are kind of the general hit lists I do when I find a URL or a remote file include or something that takes a path or something like that. So those can also work with local file includes as well. They're also represented inside of the seclist project that had the local file include fuzzing strings in there as well. So so you can kind of combine all three of those slides in together into kind of like an ultimate read and cheat sheet there. Some more common parameters: file, folder, path, style, template, anything with path in it really, document, root, or PDF or doc. Anytime it's referencing any type of these things, it has to load from a URL. That's the kind of place you want to be looking for remote file includes and redirects, and try to include code that's not your own or local code or redirect to another site. So cross-site request forgery. So everybody really knows how to do cross-site request forgery. It's kind of easy in Burp. Nowadays, you find a security-based function, a sensitive function, something like changing the password or adding a user to an account or something like that. You find that post request inside of Burp, you right-click and you choose create a proof of concept CSRF attack, and then it gives you the code, and then you submit and you win the bounty, right? So this is like super easy nowadays. To do a CSRF proof of concept and to just set it up and everything like that. And so what you want to focus on when you're doing CSRF testing that have protection, you want to focus on CSRF bypass. So some common bypasses when looking at cross-site request forgery are removing the CSRF token from the request, removing the CSRF token parameter value, adding bad control characters to the parameter value, using identical parameters, and maybe it's only parsing one or two of them, and then changing the request method. So there's some cool tooling in this section that I think is going to underrepresented, and I hope that it gets updated and fixed. I'm not actually sure if it's working 100%, I think it is. So there's a script that Tobias Mandal wrote called Burpee. And what it does is it automates a lot of those bypass methods in the previous slide so that you can do it across a whole domain. So what you do is you enable logging in Burp and you crawl a site completely executing all the functions, and then you create this template to tell his script what the parameter is, what the CSRF token is and what it looks like, what the name is and what the value is, what an expected request should look like if it goes through, and what an expected request should look like if it fails for CSRF parsing. And so you basically replace some values in this template, and then you run this script across a whole burp log file. And so the reason it hasn't gotten a lot of play, I think, is because it's a Python script that runs on the burp log file instead of an actual burp extension. So the burp extensions actually have their own store inside of burp, and you can browse them inside of burp. This one is just a Python script you run on a log file. So what you do is you run this on the log file, and it outputs a HTML report, and it shows you basically places where CSRF bypass might have been available. So this is one of the output pages. It's an HTML visualization. So here's the base request of, he found CSRF bypass on Facebook and Twitter using this tool when he first wrote it. So here's the base request. Here's a token removed from the request. And then the timeout here. So this one actually didn't find a vulnerability. It says the session timed out. So that means that the CSRF protection worked. But you receive a prioritized report of every place that it might not have worked by diffing the response types. So it gives you a whole output of where CSRF bypass might be available. And this actually, it's going across your whole burp log file, which means that it's testing all of the posts that you made when you were proxying your site through burp. So really you can go across a whole domain and test for all CSRF bypasses against all post requests or sensitive requests in kind of like a few minutes after editing that template. So it's a super sweet tool. I highly recommend it. It saves a lot of time from doing this manually inside of burp. Another way you can do it is just check for any request that didn't include the CSRF token. So here's another script that you run on your burp login file that went underrepresented, and basically it will just search for any request in your burp log file that didn't include the CSRF token name. And so that one there's a link there for that script as well. Just some general guidance as to what is like a security critical function or something like that. So add and upload files, change a password, change an email, transfer money or currency, delete a file, or edit the profile in any way. Those are usually the top hits you want to check when looking for CSRF. And then also for CSRF bypass on those particular places. So the last area is privilege. is privilege, transport, and logic. I have to apologize. My headset keeps on going out for some reason. My bad. Um, so these are often blurred. So privilege, logic, and auth bugs are usually blurred. But you want to test basically user roles. So an admin has power to do some function. A regular user has none. And so you want to make sure that the regular user can only use functions meant for himself and not the admin. So that's the basics of testing, privilege escalation or something like that. Some common functions or views here: add a user, delete a user, start a project, campaign, or whatever your site does, change account info, view pages that contain customer analytics or PII or payment processing. So those are all different types of views in the application, and being able to directly view them like an indirect object reference kind of attack is one thing you want to check as well. And so with these, there's some pretty cool tooling here as well. That's a burp plugin that I use all the time. So this one is called Autorize. Now what you do is you browse using a higher user privilege once you have this extension installed, and then you log in with a lower privilege user, and Burp will re-request everything that you did in the first session with the second session and color code anything red that it was able to get to. And so you just basically go through those links to see if they were functions that were only supposed to be available to the admin. So this really speeds up the testing for this privilege escalation type attack scenario thing. So Autorize is a really cool tool to do this kind of stuff. So IDORs are another big one in bug bounty testing. So basically find basically numerical identifiers in the URL that represent a client or some type of document or something like that. Any numerical identifier, and what you want to do is increment it, decrement it, try negative values, and try to use it and try to access it with a different user, submitting a different user ID. And so you can do this on like the change password, or the forgot password, or admin only functions. The OWASP page on IDORs is pretty good. Some common functions and views or files that you want to look for when you're testing for insecure direct object references is everything from the CSRS table that we talked about earlier, trying those same things but with a different user account, trying to access stuff that's not yours. Anything that has what looks to be like a URID or a user hash or an email, you want to try to reference as images that are not supposed to be publicly available, so just directly referencing those without maybe authentication. Any type of receipt or private file, like PDFs that are only supposed to be contained inside of the application, you want to check for those both without authentication and as a different user, and maybe as a different privilege level. Shipping info and purchase orders, that's a big one. That happens all the time. So that happened to me just a while ago. I ordered some headsets, actually the headset I'm wearing right now, which cut out. And the company had a way to track your orders, and it was just a numerical ID. I rotated it down one, and I found out that I got somebody else's order information, which included their credit card and stuff like that. So this stuff still happens if sessions aren't coded correctly or authorization isn't applied to certain parts of the application. So make sure to check for these type of things. This is just a simple example. I think everybody's seen an IDOR before, but here you can see a statement in the upper left top part, and the charge equals 28875, and you can see that the attacker basically changed it to 28860 in the bottom page, and he got somebody else's statement for this site. And Parse was actually running a bug bounty, and this was disclosed, and they have fixed this. So simple attacks, but the problem with these things is that scanners can't find these things, right? All they see is like numerical values in the URL, and they'll test it for injection, but they have no context as to whether this is a vulnerability if they change that number. So scanners will never find this type of thing, and sometimes this type of thing is very security critical. So you have to keep an eye out for iterating through any numerical values you find when testing. So transport, most security concerned sites will enable HTTPS. It's your job as a tester to ensure that they've done it everywhere. There's some instances where sensitive images gets transported over HTTP instead of HTTPS when they're going to offsite offsite sites, not the main domain, but maybe they're hosting their images on like AWS or something like that, or ad or analytics scripts are sending information over HTTP. So what you can do is you can use this script as well. This is another one that parses a burp log file, and you basically spider the application and generate a sitemap, and then select everything that you want to test and copy all those URLs into a text file, and then run this script on that text file, and it will basically try to find any of those that will resolve over HTTP instead of HTTPS. And then if there's sensitive information in those requests, then you can report that as a vulnerability. So this is a really fast way to go over a whole domain to do that type of testing. So just some logic flaws. This is actually one of the areas of the presentation that needs to be added to a little bit, but logic flaws are tricky and mostly manual. There's not a great way to automate them, but one of the best ones that I've seen in the research was substituting hash parameters. So basically a site might have a price parameter at some point during a post or something like that, but it's this long hash, and that hash is irreversible. You can't figure out how to change it or something like that on your side. What you want to do is you want to start looking at hashes across the whole application and maybe different items. So that, say it was an e-commerce site and you wanted to buy something, so try to buy something small, like a headphone splitter or something like that. That's like $5, and then find that hash and copy that hash, and then because it's in the price parameter, and then try to buy something large and substitute that hash for the price there, and maybe bypass some logic that they have and be able to pay for the more expensive item with the smaller item's price. I've seen that. Step manipulation is a pretty generic example of logic flaws. So where you have maybe an e-commerce site or some type of site that has multiple steps where you add something to your basket, you set the quantity, you pay, and then you ship. Well, what if you do everything except for pay and you skip the request that shipped, and you skip the request and then go to shipping? That's a pretty standard kind of view of logic flaws, and it still happens a lot. Using negative values and quantities is actually still happening a lot too. So when you have a quantity parameter, changing it to a negative value will actually force the site to apply credit to your account in some cases. That actually happened really recently in a test I did. Authentication bypass, there's a whole section to authentication bypass, but another cool one is application level denial of service. So this actually happened recently as well, where some applications are just not set up to handle really large parameter values. So just adding a huge length parameter for the page to parse will actually DOS the application, or adding some kind of mathematical function where the server has to work really hard to do a function as part of the parameter value will DOS the server, as well as there's a whole bunch of logic timing attacks. And so this is a place I'm going to expand upon to kind of show some of these attacks in action, but these are mostly manual testing and very application specific as well. So mobile is a section here that I wanted to cover a little bit. So most of the mobile application vulnerabilities you'll see nowadays are due to unencrypted data somehow on the phone, and so data storage is a big thing. So if you don't have a passcode, or your passcode is 4 digits, it can easily be brute forced at one point or another. And then there's also just some data storage techniques that people use that are just unsafe in general. So one of those is the phone system logs. So logs on both Android and iOS up until recently, I think, any logs that an application you have sends are available to everything on the phone, every other application on the phone. So a lot of ad or analytics libraries will copy your logs and send them to do analytics on them, which could include private data. So we've seen a ton of people basically logging usernames and passwords or personal identifiable information, bank transactions, with including like routing numbers and amounts that were spent or transferred and things like that. All those type of things being sent to the logs, and then any other application can pull those things out. So you want to look for those right away. Caching of data because of the application uses WebKit or something like that. Those files aren't superly well encrypted, so you want to check in those caches, usually the cache.db file inside of a mobile application. Any data storage mechanism, either a plist, a database, or just a text file, um, you have to ensure that they are encrypted at all with the platform's data protection API or something like that. And then also you want to look for anything hard coded in the binary like API keys or something like that. And so these are quick hits for when you're doing like a mobile app to try to find these things and submit. One of the things I really like in the mobile space right now is this tool called IDB, written by Daniel Mayer. And basically, I did a talk on my methodology for testing mobile apps a long time ago, and he took all the information there and turned it into a GUI tool so that anybody could really get started with this. So all you really have to do is jailbreak your iPhone um, using whatever jailbreak you want to use, and then connect it to or download this application and connect it, and it will set up all your dependencies for you, and then connect to your iPhone, and then you have a testing environment. And so you start it up, and you get this window, which is represented here, and you select an application on your phone, and then it will automatically connect to the phone. It will tell you if the application has all of the proper um, exploit mitigations built into it, if it's encrypted. It has a GUI browser for all of the folders inside of your application. It will tell you how the application passes files. It'll tell you all of the encryption levels to each file it has found. It will parse the logs of the phone to tell you if that application is leaking data to the logs, as well as check the keychain and the copy and paste buffer and all kinds of other mobile vulnerability areas that are common to have to monitor for these type of things. So IDV is super cool. It's what I train with anytime I train somebody new for doing iOS testing. On the flip side of this, if you're on the Android side of the house, you really want to get comfortable with Drozer. I don't have a slide in here with that. It's more complicated than IDB. It's not a GUI tool. It's a command line based tool, but Drozer is probably the best tool out there to do Android assessment at the moment. That's open source. So here's an example of the logging, right? So we're catting out the value of a log file. Here you can see that entered password is pass, login failed, and then entered password is password, successful attempt. This is very indicative of what you'll see in a mobile application nowadays, and putting it in this log file has now made it available for any other application on the phone. So just some extra stuff. These are more vulnerabilities that usually are not included in the scope of a bounty. But might be useful in taking notes and actually leading to different attacks. So content spoofing or HTML injection, refer leakage, security headers, path disclosure, and clickjacking. They'll most likely always come up in a different context when you're trying to chain two attacks together, so just keep notes on these when you're doing your bounty hunting. There was this idea that a friend of mine, Daniel Miessler, came up with on how I could take all the research I parsed and yield maximum results within a given time window. And so this is actually something I don't really like when people come up to me and are like, can you find vulnerabilities in a site within like 30 minutes, right? And in the bug bounty community, that's actually what you're doing. But for an actual assessment, I hate when people put on that time constraint. But we decided to kind of put through a hit list of what we could test in how many minutes with maximum results. So this is what that kind of looks like. So you visit a site, you use the search and the registration and the contact and the password reset and the comment forms, and you hit them with the polyglot strings that were earlier in the presentation. Then you send you send those specific functions to a scanner, right? Whether it's burp scanner or something else like that, because you're not going to have time to manually fuzz everything. So you automate that part. You check the cookie, the logouts, the login to see if you still have access for basically session-based vulnerabilities. You check to see if the user form is enumeratable. You do a password reset to see if it comes back as plain text or predictable, or it can be used multiple times or logs you in automatically. And then you go through your log files or your burp session data, and you find any numeric account identifiers anywhere in the URLs and rotate them to see if you can get an IDOR or something like that. Then you find all the security sensitive functions inside the account and see if they're vulnerable to non-auth browsing, which would be an IDOR, lower auth browsing, CSRF protection bypass, and to see if they can be done over HTTP. either before you do that or after you do that, you use a directory brute force list from seclist, probably the raft list, that's the smaller one, to find for unlinked content that might be dangerous. And then you check upload functions for file types that can execute code like XSS or a web shell or something like that. So you can probably do all this within 15 to 30 minutes, maybe an hour. I don't know. I put 15 minutes here, but it's probably more than that. So yeah, I mean, it's kind of a data-driven assessment based on the research here. Obviously, it doesn't contain everything, but it is kind of a way to start. So things you can take with you. So crowdsourced testing is different enough to pay attention to. Um, it, the amount of tooling that goes into it to make it faster and the amount of methodology to find edge cases is really important. So you should be following these bug hunters or the bug hunting type of research or methodology that comes out of it. Um, Crowdsourcing, basically focuses um, on finding the edge cases instead of the larger regular AppSec vulnerabilities. We can create methodology out of data analysis, which is what we did here. Maybe a 15 to 30-minute test done right could yield some critical issues. Polyglots are really cool. SecList is a really cool project. And everyone who I profiled for this is in a Twitter list, so you can click on that link and basically go to that list, and it has all the ninjas, I call them, who I parsed information from, and some extra ones as well, who I think are just super cool. So you can go to that list and monitor what they're talking about and maybe find some new methodology tips. That's what I'll be doing to keep up this methodology in the future. So there's a lot of stuff in this presentation. It ended up being way too much to fit into a 45-minute or hour talk. So we're turning it into a Git project. It hasn't happened yet. I plan to do it really soon, hopefully. Just got back from DEF CON and it was a crazy week. So, but 50% of the blog research that I parsed out is still not represented. There's more tooling to automate some of these things represented in there. I have a whole section about X6E and parser attacks, SSRF, CAPTCHA bypass, more detail on the logic flaws, and more detail on mobile tooling and mobile flaws. So that's all planning to go into the GitHub. It'll be on my GitHub, which is linked here. And you can also check my Twitter. I'll make sure to tweet it out when I get it done. But yeah, basically, it'll all be done via Markdown, and so you won't have to look at a presentation like this, and it'll have all the links and resources and any kind of write-ups I can do on anything there. And I'm hoping that turns into like a community project. Maybe the bug hunters come in and add to my methodology or the stuff that I parse, and it can just become a living document. I'm pretty hyped about that. So only 13 memes through all slides. That's pretty good. And these are all of the people that I referenced in the slides. So everybody who made a tool or provided a string or did some research I thought was really sweet. And then everybody on my team at BugCrowd that helped me edit the presentation and just generally supported me for doing the talk, which is John Cran, Todd, Spend, Ben, Grant, Fatih, Patrick, Katie, Kim, Abby, Casey, Chris, and Sam, and every bug hunter who goes out there and does this every day, not only just for money, but to help make sites better and more secure. So that is the presentation.